Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 16 to 20 of the January 2018 Algebra 1 New York Regents exam. Alright, let's take a look at question 16. It reads, the 15 members of the French club sold candy bars to help fund their trip to Quebec. The table below shows the number of candy bars each member sold. So we have the number of candy bars sold by the 15 different members of the French club. Question: when referring to the data, which statement is false? So before we start examining each statement, some few things to keep in mind. The first thing has to do with the measurement of central tendency. Okay, so note, first one, mean and median are the preferred tools other preferred tools to measure central tendency. Okay, and another thing to note has to do with what an outlier is. Okay, so if you hear the word or see the word outlier, what does that mean in a statistical context? An outlier is an extreme high or low in a given data set. Okay, so if you have a collection of points and one is extremely high relative to the others or extremely low, then that point is considered an outlier. Alright, so with these 2 points in mind, let's take a look at the question. Question 1. The mode is the best measure of central tendency for the data. Is this true or false? This is false. Why? Median and mean are what statisticians use to measure central tendency and not mode. Okay, so let's take that out. The next one, the data have 2 outliers. Okay, before we go into that, the question asks for which is false. So the answer should be option 1. That's the false statement, because the best measure of central tendency for the data is going to be either the mean or the median. Alright, now these other 3 statements have to be true, so let's go ahead and examine them real quick. Number 2 says the data have 2 outliers. So how can we determine what an outlier is when the data is presented in a numerical format like this? All we just have to do is we're just going to order the numbers in increasing order and take a look at the change when in change in magnitude of numbers when you go from one data set to the other. Okay, so when you see a big change, then you can easily determine where the outlier is. Alright, so let's go ahead and write down the numbers we have. We have 0, 35, 38. The nice thing about this data set is that it has already been ordered for us. And if you notice in part 3, we're looking for the median, and then we're also looking for the range. In order to accurately determine these, your data set must be sorted in ascending or descending order. Okay, 43, 45, 50, 53, 53, 55, 68, 68, 68, 72, and 120. Okay, so to see where the outlier is, let's take a look at the growth. Okay, so from 0 to 35 is plus 35. So what we're going to look at is the growth relative to each other. Okay, so from 0 to 35 is a jump of 35. From 35 to 38 is a jump of 3. From 38 to 41 is a jump of 3. From 41 to 43 is a jump of 2. From 43 to 45 is a jump of 2. From 45 to 50 is a jump of 5. From 50 to 53 is a jump of 3. From 53 to 53 a jump of 0. 53 to 55 a jump of 2. 55 to 68 13. 68 to 68 a jump of 0. 68 to 68 a jump of 0. 68 to 72 a jump of 4. And then 72 to 120 is a jump of 48. Okay? So take a look at all these numbers right here. Do you see any number or set of numbers that are really big, like a really big jump? Now take a look at this. From 0 to 35. This is a jump of 35. That's a big jump. Okay? And if you look at everything else, do you notice any other considerably large jump? Right here, 48. That's another big jump. Relatively speaking, 13 is a little bit big, but compared to 35 and 48, this is nothing. Okay? So these two are the outliers. We have this 0 is like a big, is an extreme low, and this 120 right here is an extreme high. Okay? So this setup basically indicates that we have there are two outliers in this data set. Okay, remember the definition of outliers we indicated earlier. It is an extreme high or low in a given data set, and we have two of them here, so option 2 is true. Alright, let's take a look at option 3. Median is 53, so median is basically the middle number in the data set, or the average if you have two numbers occupying the middle. Okay, so let's see how many numbers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right, we're told that there are 15 of them. So which number resides in the center? So if you take a look at 15, you just subtract 1 and divide by 2. So if you take 15 minus 1 is 14 over 2, you have 7. So you have 7 to the left, 7 to the right, and then 1 in the middle, and that one will be your median. Okay? So either you count 7 from the max or count 7 from the min. Whatever number comes after that or before that, that's your median. Alright, let's count from the bottom. 1, 2, 3, 4, 5, 6, 7. Bam. There goes your median right there. Okay? You can count from the top to 1, 2, 3, 4, 5, 6, 7. And then you end up with 53 as your median. Alright? So option 3 is true also. Option 4, the range is 120. Is that true or false? So for that, if you want to compute the range, you just simply determine the difference between the maximum data set minus the minimum, and that will give you your range. Okay, so in this particular data set, the range is going to be the max, which is 120, minus the min, which is 0. 120 is the range. Option 4 is true. Okay, so we can clearly see that the only false statement is option 1, because mode is not what's used for, it's not the best measure of central tendency. Alright, let's take a look at question 17. It reads, given the set x such that x is between -2 and 2, where x is an integer, what is the solution of the inequality -2 times the quantity x minus 5 less than 10? Okay, so what we are doing here is we're looking for a set of solutions that satisfies two conditions. First of all, it has to satisfy this inequality, and then it has to satisfy this set of integers right here. Okay? Alright, so what we're going to do is let's go ahead and solve this inequality first, and then write down these two conditions and see the intersection of the conditions, and that will be our correct answer. Alright, so we'll start by solving. We have negative 2 times x minus 5 as less than 10. So we're going to distribute negative 2, or instead of distributing, we could divide, but let's just distribute the same thing. Alright, distribute negative 2 across those two. And then we have negative 2x plus 10 as less than 10. And then we subtract 10 from both sides. Remember, when you're solving an inequality, it's very similar to solving an equation. The only difference is that the inequality sign could change whenever you multiply or divide by a negative. 10 minus 10 is 0. And then we're going to divide both sides by negative 2, or multiply by negative 1/2. So it's the same thing. And then you have x. Now, if we are dividing by negative, how does that impact the inequality? It changes to greater. Okay? 0 over negative 2 is 0. Okay, so we have the first condition, and what satisfies this equation right here? Any positive real number will satisfy this inequality. But we have another constraint, which is this set. Okay? The set x such that negative 2 is less than or equal to x is less than or equal to 2. Right? Where x is an integer. So you need to know what your integers are. Alright, so if I want to graph this one, the first solution is to be a number line where we have zeros excluded. So you have an open circle and everything to the right greater. Okay. What if I wanted to graph this set right here? On the number line, it will be points. Okay, they're integers. So let me show you what this looks like. Negative 2, negative 1, 0, 1, 2. So if I want to graph this condition right here, it will be a point here, a point here, a point here, a point here, and a point there. Okay? Now what we're going to do is we're going to look for the intersection of these two situations. Okay? So this is a set, and this is the inequality. So we're looking at the set of numbers that satisfy both conditions. So what is the answer going to be? It's just going to be basically the intersection. Okay? So out of all these numbers here, negative 2, negative 1, 0, 1, 2, which of them are greater than 0? That's basically what it's saying. Okay? You can't pick 0 because we have an open, there's no line of inclusion here, so 0 is excluded. So the only numerical values that satisfy both conditions are 1, because you have 1 right here, and 2. Okay? You have a point 1 right here on this number line, and you have the point 2 right here on this number line, and you have point 1 here on this set of integers, and point 2 here. So the two numbers that satisfy both conditions are 1 and 2. Okay? So the answer to question 17 is option number 2. Alright, let's take a look at question 18. Alright, let's take a look at question 18. It reads, if the pattern below continues, which equations is a recursive formula that represents the number of squares in this sequence? Alright, before we get started, let's refresh our memory on what a recursive formula is. Okay, so what is a recursive formula? You have to remember the following fact concerning recursive formulas. Okay? First thing you want to note is that a recursive formula has two parts. Okay? So a recursive formula recursive formula has two parts. What are they? It has the initial term and secondly the recursive relation equation. Okay, the recursive relation equation, or it could be called recursive definition. Alright, so what we're going to do based on this point here is examine the options we have and see which equations have two components, a starting term or the initial term and a recursive definition or relation. Alright, option 1 is a function. This is just one equation, so it doesn't qualify as a recursive formula. Option 2 is just a function, doesn't qualify as a recursive formula. Option 3 and 4 both have two parts. Initial term, normally A1, and the recursive relation equation. So these two are good. So which of these two adequately represents the sequence here? You can just study the sequence and see how it grows. Okay, so you have 1, 2, 3 here. Here you have 1, 2, 3, 4, 5. If you examine these two, you notice that two more boxes were added on. Okay, so from this to this, you added 2 plus 2. And then here, what you have 1, 2, 3, 4, 5. Here you have 1, 2, 3, 4, 5, 6, 7. What happened? Another two boxes are added onto the ends. Okay, so you have this arithmetic sequence where two boxes are repeatedly added on. Alright, so you initially started with 3, so that's your initial, and then to get the next term you add 2. So take a look at these two options here. Which one has the first term? A1 equals 3. First term is A1. If you look at the index, it tells you the position. Okay, A1 is the first term. This is A1 right here. So which one has A1 of 3? Option 3, so that's automatically your correct answer. If you look at the recursive relation equations, both of them are identical. They're both correct. But what sets this apart as the correct one is because it has the correct initial term. Both of them have the correct recursive relation equation because a previous term plus 2 generates the next term, and that's what's manifesting itself in this arithmetic sequence. Alright, so answer to number 18 is option number 3. Alright, let's take a look at question 19. It says, if the original function f of x equals 2x squared minus 1 is shifted 3 units to make is shifted to the left 3 units to make the function g of x, which expression represents g of x? Alright, so let's go ahead and review our formulas for transformation. We're just going to look at shifts, okay? Because that's what we're dealing with here. We just have a shift here. Alright, so if you have a function composed with x minus h, so the minus affects the x directly since they're grouped together. What kind of shift is this? This one indicates that you're going to shift h units. So shift h units. Where do you think the shift is going to go? You have a minus here. You think it's going to the left or to the right? Well, when it's grouped with the x's, the opposite happens. So when you have a minus, is actually to the right. H units to the right. Okay, so don't forget that. If you have a function composed with x plus h, guess what? This indicates a shift h units to the left. It's backwards. How about if you have a function plus k? This one indicates a shift. This one is either up or down. What do you think it is? This one is actually k units up. So the k's make sense. whatever you're adding or subtracting to the function just shifts it up or down depending on the sign. But when it's composed with x, you do the opposite. Okay, so f of x minus k, this you might get is a shift k units down. Okay, so in this problem we are shifting 3 units to the left, so we are going to be using this first formula right here. No, not the first one. To the left is the second one, so we're going to be using the second one. Alright? Okay, so what we're doing is we're going to shift 3 units to the left. So that's going to be, g of x is going to be defined by f of x plus that h value is shifting to the left by, which is 3, so f of x plus 3. Okay? So we know what f of x is, right? F of x is 2x squared minus 1. So let's write that down. F of x is 2x squared minus 1. So what on earth is f of x plus 3? So let's do it. So f of x plus 3 just basically means that wherever you have an x in f of x, you replace it with x plus 3. So 2, instead of x, guess what? We're going to replace that x with x plus 3, which causes the quadratic to shift 3 units to the left. Okay? So 2 quantity x plus 3 square minus 1 is what we get when we replace this x right here with the new input value, which is the shifter x plus 3. Okay? So this is basically what g of x is. So g of x is 2 times the quantity x plus 3 square minus 1. The answer to question 19 is option number 2. Alright, let's take a look at question 20. It says, first consider the system of equations y equals negative 1 half x plus 1 and y equals x minus 5. Then consider the system of inequalities. Y is greater than negative 1 half x plus 1 and y is less than x minus 5. When comparing the number of solutions in each of these systems, which statement is true? So we are comparing the solutions to a system of equations to the solutions of a system of inequalities, both linear. Alright, so what we're going to do in order to avoid being too abstract is we're just going to go ahead and graph both of them, okay? And then when we're done graphing, we'll just compare them and see what the correct answer is. So let's start with the system of equations first. So we have y equals negative 1 half x plus 1. So in this case, you remember y equals mx plus b, okay? If you have y equals mx plus b, m is your slope and b is your y-intercept. So for this setup that we have here, your slope m is negative 1 over 1, which means you rise negative 1 and run 1, starting from your beginning point of y of 1 on the y-axis. That's your y-intercept. Alright, let's go ahead and graph that. So there goes my y-axis and my x-axis. So y-intercept is, I'm going to make the first line blue, okay? Y-intercept is 1, so I'm going to rise negative 1 and run 2. So you run 2 because it's negative 1 half, that's your m. So we're going to rise negative 1 and run 2. 1, 2, bam. Alright, so let's draw the first line, okay? Alright, so this is the first line right here. And then we're going to draw the second line and talk about what the solution is to that system of linear equations. Okay, so now let's take a look at the second one. I'm going to make it greener. Alright, the second one is y equals x minus 5. So with this one, M is the coefficient of x, the invisible number, multiplicative identity, which is 1, 1 over 1, so we're going to rise 1 and run 1. Where do we start from? We start from the y-intercept b, which is negative 5. So 1, 2, 3, 4, 5. We're going to rise 1 and run 1. Let me put in more points. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Bam. Okay, so let's go ahead and draw the line um, of the second linear equation. So there you have it. So let's pause for a second and take a look at what we have. What does this graph tell us? It tells us that we have exactly one solution. Where is that one solution? That one solution is a point of intersection of the lines, the graphs of the two lines. This right here is the solution. Okay, so for this system of linear equations, you have one solution, which is an ordered pair 1, 2, 3, 4, negative 1, 4 comma negative 1. Alright, so you have one solution. Now, how about the system of linear inequalities? Well, similar to this, we're graphing the same line, but we're just going to apply effects. We're just going to shade and break lines and stuff like that. Okay? Alright, so let's go ahead and graph the second one. So for the second one, we have, we're going to do the first one in blue. Y is less than, oh no, greater than negative 1/2 x plus 1. So this one, you're going to have the same slope as the first one, negative 1 over 2. So you're going to rise negative 1, which is down, and over 2. And your y-intercept is going to be 1. But in this case, because of this inequality, you're going to have a broken line, and you're going to shade the upward direction for greater. Okay, so let me go ahead and graph the second one. So we have a point starting from 1, and then we're going to rise negative 1 and run 2. Okay, so unlike the linear inequality, the first line we drew, this one is going to be broken. Okay, so we're going to have a broken line in this case. So you're going to have a broken line, and we are going to be shading the top of the line greater. So imagine that this is a roof. Where is the top of the roof where the rain falls on to? It's going to be in this direction. We're going to shade this direction. Okay, I'm not going to shade yet because we have another inequality that both directions should satisfy. So we have to hold off on shading until we graph the second one. Okay. Alright, so the second inequality is y is less than x minus 5. So just like the previous one, we know what the slope is. 1 over 1. Rise 1, run 1. Y-intercept, where you start from, is negative 5. But since we have an inequality, there's no line of inclusion. Okay? If there's no line, that means the line is going to be broken, just like the first one. And since it's less than, we're going to shade where? We're shading below the line. Alright, so let's graph the line. It's just going to look like this one right here. 1, 2, 3, 4, 5. Okay. So rise 1, run 1, rise 1, run 1. Same point of intersection that we got before. But the difference here is that for this one, the line is going to be a broken line. Okay, so we have a broken line. And we're going to shade beneath the line. So imagine that this is a roof again. Where is the bottom of the roof? Where the rain does not touch. Down here. Okay? So we have 4 quadrants. Now our solution is a quadrant that both arrows are pointing to. You cannot go behind any of the arrows. Okay? So let me just number them for you. So you have 1, 2, 3, 4. Do you see which quadrant our solution region lies? Solution region lies in quadrant 1. Why? Because both arrows are pointing in this quadrant. What is the significance of this shading that we are just doing here? Well, the significance is that any point in this region satisfies both inequalities. Okay? So, let's write it down. All points in 1 are solutions to the inequality. So the question now is, how many points are there? There are infinite number of points on this plane right here. Okay, so there are an infinite number. How does this compare with our answer for the system of linear equations? The linear equations had just 1 point that satisfied both equations. You have just one solution here, and for the linear inequalities, you have infinite number of solutions. Okay? Alright, so let's go and see what the correct answer is. Option 1 says both systems have infinite number of solutions. This is false because the system of equations has only one. Option 2, the system of equations has more solutions. One or infinite, which is better, which is greater. One is less than infinity. Okay? So this statement is false. The system of linear inequalities has more solutions. Number 3, the system of inequalities has more solutions. Now this is true because infinity is greater than 1. Okay, or infinity is more, way more than 1. Now let's take a look at the last one just to make sure. It says both systems have only one solution. That's false also because the system of linear inequalities has not one but infinitely many solutions. So any point I pick in region 1, like I just picked this point right here, that's a solution, that's a solution, that's a solution. It just goes on and on. You have infinite number of points. Okay? So the answer to question number 20 is option number 3. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents, to give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to the other parts of this review series. More clips can be found on mathgotserved.com, and if you have any questions, just post it in the comment section below, and we'll be more than glad to support you. For access to our large collection of review videos, you can just scan this QR code or look for the link in the description below. Thanks again for watching, and have a wonderful day. Goodbye.